Okay, example 1, 2, and 3, they all involve finding sine, cosine of things. And this circle I've got drawn there is going to be the unit circle. So anytime we're dealing with trigonometry stuff and we're dealing with trying to find sine, cosine, tangent, cotangent, secant, cosecant, any kind of values of those things, we're going to start off with the unit circle. If you recall the unit circle from last chapter, it's a circle of radius 1 centered at 0, 0. So the coordinates of the 4 points on the quadrant lines are 1, 0, 0, 1, negative 1, 0, 0, negative 1. Any radius drawn in this circle will have a radius length of 1. And I want to use what's called a reference triangle to find this. We've already done this using our 30, 60, 90 relationships, our 45, 45, 90 relationships, but I want to make it even a little simpler than that by using what's called a reference triangle. All right? So if I'm in radian world, my reference triangle looks like this. I've either got a 30-degree angle, which is pi over 6, a 60-degree angle, which is pi over 3, and a right angle. Or I have a 60-degree angle, which is pi over 3, a 30-degree angle, which is pi over 6, and a right angle. So what changes the up and down, the left and right, as far as what's what? So either a 60-degree angle in the corner, or a 30-degree angle in the corner here, and the other angle up there. I want this point to be considered to be the origin. And you know what? I'm going to turn it around. I'm going to flip it that way. Sorry if you've already drawn it. Flip left, right. Let's make this pi over 3. Make this pi over 6. And the other possibility is a 45, 45, 90 right triangle in radians. Oops. That'd be pi over 4 radians. So 90 degrees, pi over 4, pi over 4. That's the origin. So, we know our relationships for 30, 60, 90 are 1, 2, square root of 3. We know our relationships for 40, 40, 45, 45, 90 is 1, 1, square root of 2. Okay? Now, specifically for a unit circle, if this is the origin, and each case, this is the point on the unit circle. Origin to unit circle, origin to unit circle, origin to unit circle. In every case, this is 1 unit, because we're dealing with the unit circle. Again, these are called reference triangles. We're going to be using reference triangles to find stuff. It'll still be there later. All right. So, if it's this reference triangle, the side opposite pi over 6 is 1/2. The side opposite pi over 3 is the square root of 3 over 2. Maybe you need a little bit more room there. If this is a reference triangle, it's the same relationship of sides, just we've switched these two sides. Now this is the 1/2, and this is the square root of 3 over 2. And for this one, this is 1, this is the square root of 2 over 2, and this is the square root of 2 over 2. Okay. You might recognize these numbers as numbers you would have gotten back in chapter 7 too, when we were drawing these things out using 30, 60, 90 relationships and 45, 45, 90 relationships. We kept on getting 1/2, square root of 3 over 2, square root of 2 over 2 as our answers. Okay. That wasn't a coincidence, that's just what they are. So as opposed to evaluating it every single time like that, we can just create a reference triangle and use that in order to figure these things out. Now, with that in mind, we need to draw a triangle in the unit circle to represent this angle and compare it to those three triangles to see which one it is, to establish what the sine, cosine of these things are. Now, for each of these, the horizontal piece of this is the cosine of the angle at the origin. So the cosine of pi over 6 equals the square root of 3 over 2. That side is what the cosine of pi over 6 is. The cosine of pi over 3 is that side, that equals 1/2. The cosine of pi over 4 equals that side, which is the square root of 2 over 2. That's the usefulness of these reference triangles. I know exactly what the cosine of each of those angles is. The origin angle, cosine is just the horizontal piece in each of those triangles. The vertical piece in each of these triangles represents the sine. So this is the sine of pi over 6. That equals 1/2. This is the sine of pi over 3, which is the square root of 3 over 2. This is the sine of pi over 4, which is the square root of 2 over 2. Our task is to find the sine and cosine of this angle. So what I need to do is I need to draw that angle on the unit circle in standard form. Recall your unit circle has 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. All right, so that's one trip around the circle. 2 pi radians is one trip around the circle. If I'm dealing with 2 pi over 3, I'm splitting pi into thirds, right? So if you recall how to do this, this is pi, split it into thirds. I want 3 equal sections. So section 1, section 2, section 3. This is pi over 3, this is pi over 3, this is pi over 3. If I'm measuring an angle in standard form, measuring from 0 counterclockwise around the unit circle, there's my initial side. My terminal side would be 2 pi over 3, which would be right here. Okay, so this is 2 pi over 3 radians right here. Again, that's how we draw it inside the unit circle. If it was something pi over 6, I'd break that into 6 equal sections. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Again, you have pi, one whole pi, you're breaking into 6. If it was fourths, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So again, you're breaking it into equal sections. Whatever the denominator is tells you how many sections to break it into equally to get you an idea of where things are. Now, by putting all the pi over 3's in there, notice if I were to draw this line straight down here like so, I'm looking at the reference triangle where the origin angle is pi over 3. This is the reference triangle I'm using. Cosine of pi over 3 is 1/2, so the length of this piece here is 1/2. The sine of pi over 3 is the square root of 3 over 2. The length of this piece is the square root of 3 over 2. Which direction is the half going from the origin? If I'm here, I'm going this way. Which direction am I going? Going left. If I'm going left, what sign should I put?
Negative.
Negative. Which direction am I going to get to this object from the x-axis?
Up.
Up. If I'm going up, that should be positive. Okay. The answers are always these numbers. They're either positive or negative, those numbers. So it's up to you to determine, based on its position, what quadrant you're in, which direction you're moving. I'm moving left, so that's negative. I'm moving up, so that's positive. The number's 1/2 because the number's 1/2. The number is the square root of 3 over 2 because the number is the square root of 3 over 2 because my origin angle is pi over 3. Use your reference triangles to establish the sines and cosines. This is cosine, this is sine. So My angle I'm working with is 2 pi over 3. Cosine equals -1/2. Sine of 2 pi over 3 equals positive square root of 3 over 2. I would have this in your notes. Refer back until you don't have to. Those should become commonplace not numbers that are just stuck in your brain. But as long as you have to look them up, draw the picture on your paper until you don't have to look them up anymore. But again, the angle we're working with is 2 pi over 3. That puts us left and up, which makes cosine negative, sine positive. The numbers are what they are. Anytime I see anything with a reference angle of pi over 3, this sine and cosine every time. I just have to determine whether they're positive or negative based on their position.